In the sprawling expanse of the cosmos, where light years separate the celestial dance of galaxies, there's a peculiar species on a tiny, water-rich planet who dare to mimic the grandeur of the universe on a tiny, tiny canvas. Today, we'll build the solar system with Three.js, a voyage where our spacecraft is powered not by ion thrusters, but by shader materials and the existential operator. Let's sculpt the sun, the planets, and the stars, not merely as they exist in the cold void of space, but as they bloom in the wild garden of our imagination. Okay, let's build a solar system. We're going to start from this basic template, and we're going to build it in about 7 different steps. Build what? This. We'll start by creating the sun and create a solar system group that will include everything you see here. We'll add another nebula. I want on either side of our solar system to have a couple of contrasting nebulas, so one with a warm hue and one with a dark hue, so that it looks cool. It's really all I care about is that it looks cool. We'll add the planets, their rings, and the moon. We'll add the asteroid belt. Add a bunch of lines around the elliptic plane, that plane that extends out of the equator of the sun, and then we'll animate the camera. That should do it. So those 7 steps. Let's get underway. Let's start. We've got our imports, we set up our scene, our camera, and our renderer, and we instantiate our controls. Const solar system equals a new group, and we'll add that to the scene. I've already created a file called getSun, which I'm going to use to create my sun. Here's what that looks like. Import getSun from source.getSun. And my sun will equal getSun. And solarsystem.addSun. Let's get rid of this geometry. We don't need that anymore. I'm going to leave that for the moment. Excuse me. And get rid of this. There's our sun. Our sun has an update method, which I want to call. But well, it looks like this. sun.userdata.update. And I need to pass in time, which is going to be just a number that counts up from 0. If I just add t, hang on a second, I want to get ready for this because it's going to be really awful. Const time is equal to t times 0, 0, even a little bit slower. So if I just pass in t, it's going to be really chaotic, but if I update it to time, then you get this kind of cool effect. This is my proxy for a sun, like the corona of the sun. Hi, Future Bobby here to talk to you about this getSun method. Inside it, I'm using improved noise to create that kind of corona mesh to give that cool effect to the sun. For an overview of how that works, check out my previous videos on noise. There's curl noise, there's the noise grid video, and there's also particle effects with noise. Check them out. Thanks. Let's add our star field. We're going to do that by going import get starfield from source get starfield and instantiate it. Starfield will get starfield, scene.add starfield. La la la. We can pass in the num stars if we want. Num stars is 1,000 or 100 or 10,000. 10,000 looks kind of cool. I want to change this Starfield API to pass in the size, the average size of the star, but I'm not going to do that yet. But I really want to. Size is equal to, let's say 0.1. I don't know what it's set to at the moment, but let's have a look. Size equals 0.2. That's the default. And we'll pass in size here. Oh, look at that. They're a lot bigger now. So if I wanted to, in this solar system 11 index file. I could drop the number to, say, 500 and make them just a lot bigger. I don't know. Is that better? I kind of like them bigger for the sake of this demonstration. Now that I've got stars, I've got the sun, I'm going to add another nebula. Just copy this and call this another nebula. Oh, I don't know. Oh, that's really too bad. That's not at all what I wanted to happen. There. This one will have a hue of a 0. And I want it to be on the other side. So as I pan around, then I'll see it over here. I also want to push these guys way back, like so. And I want their size to be a lot larger. And let's see, the radius. I think that's going to be 40. Like that. Opacity's 2, num sprites, let's make that 10. Good. Now I've got stars, a sun, a couple of nebulas. Ooh, it's pretty. What's next? Planets. Let's call this, no, we don't need one of that. Our code is named in such a way that it should make comments unnecessary. At least that's the goal. I'm going to drop the stars size down a little bit. They're a little bit too big. Let's add our first planet. Let's call this Mercury. Is get planet. Let's include our get planet method. Get planet. Great. To get an overview of how the get planet method works that we've imported here, go back and watch my Earth video. Create the Earth with Three.js. Thanks. This API is set up so that you can pass in a size of the planet. Is that a radius or a diameter? I don't know. Maybe it's a radius. You pass in the distance from the sun and a texture map. And let's solar system dot add Mercury. Boom, there's our Mercury. Hello, Mercury. Just make sure this is anti-aliased because it looks a little bit crufty. Is that better? I think that's better. I think every time I add anti-alias to the WebGL renderer, I look and I have trouble telling if it made a difference or not. So adding Venus, adding the Earth. We're going to want to add a moon to the Earth too. So const moon equals get planet, and we'll pass children moon. We'll pass that into that get planet method, and now see our Earth has a moon. It's also rotated really weird. And there's this artifact from the texture, which I'm not going to fix. You can see a little jaggy line. Let's just pretend that that's a giant human construction. All right, moving on to Mars. It's Mars is equal to get planet, and then solar system.add Mars. Great, we've got the inner rocky planets. I think this is the right time to start animating these guys. Let's go up to our solar system, and we're going to create a method that's going to handle all of that. It's this update method. I'm attaching it to the user data object, which is specifically designed so you can cram it whatever you want in there without accidentally clobbering Three.js properties or methods. I'm using this existential operator here that says, hey, do you have an update method? If so, call it. Otherwise, don't. It's the same as writing an if statement here. So that's in place, but I need to call it, let's call it like this. Down in my render, my animate method, I'm going to replace that sun update method with a solar system update method. And because it's calling it on all its children, each of the planets is orbiting now, and the sun continues to update. Great. Let's add the rest of the planets and the asteroids. You know what? I think I'm going to do the asteroids now because that's the sequence. Const asteroid belt equals get asteroid belt. And we're going to pass in OBJs. What the heck are OBJs? Well, I'm glad you asked. We're going to import an OBJ loader. Thank you. And then down here, we're going to load them. Rather than type out all this stuff, let's see. How about this? Load rocks. OBJs, loader. Nope. Nope. That's not what I wanted. I'm going to copy it from my other file. Here it is. Okay. I like to set up a container for the stuff I'm loading. In this case, I'm calling it scene data. It's got one property, this objects array. As I load these rocks, these rock OBJs, I'll pull out the mesh and put it into this objects. And I've got this line here that says when I've completed loading everything, call this init scene method, passing in that collection of objects. We don't have an init scene method. Let's create one. I'm going to wrap everything we've done so far in a function declaration or a function expression. One of those two. Function init scene, and I'm going to pass in not OBJs but just data, because we're going to unpack the OBJs like that. Let's format. I typed Shift Option F on my keyboard to format, and now, boom, I've loaded the OBJs. But I don't see them yet. Did I not add them? And then let me add them to the solar system. Look at that. Isn't that nice? And that kind of clues us in that we need to rotate the camera a little bit. Gosh, I love the look of those asteroids. The camera position is set here. 0 on the x-axis. I don't know. 1 on the y-axis and 3 on the z-axis. How's that look? Way too close. Okay, that's pretty good. Or a lot more there. That works for me too. Next, Jupiter. Or do I want to mess with the light? I think I'm going to copy over a light I had in the other scene. Right now, if I pull out that hemisphere light, we're just getting the light from the sun, and the sun looks a lot better too, doesn't it? So let's just pull in that. I could just define it myself, but I really like the setting I had here, so I'm just going to grab this one. And it's a directional light with this kind of blue, teal kind of, and that's going to color everything that's not being illuminated by the sun. It gives the sun a little bit of a tint as well, but I don't care about that. Great, moving on to Jupiter. Get planet. I'm just taking what GitHub Copilot is giving me. I could kind of smoosh these a little bit closer together, but I'm not going to. And then solar system.add Jupiter. There's lovely Jupiter. Is it big enough? Should it be a little bit bigger, like a 4? Because I mean, it's Jupiter. All right, let's add Saturn. Saturn, boom. And it's not really Saturn without its ring, so let's create a ring. Const s ring geo is equal to a new, sorry, I want to use a torus, which is another, it's a donut, because it has a little bit of height, and I want that then when the sunlight shines on that little bit of height, it's going to give you some nice detail. So that's why I'm using that instead of ring geometry. I'll use a mesh standard material, and the color I am not defining. Let's see. Nope, I'm not using a map. I am const Saturn ring is equal to a new mesh, passing in those guys. And now, oh yeah, that's fine too. I don't like that divided by 2. I like just superstitious about that. Pass that in as a children array. And there you go. It doesn't quite look right, does it? It's way too small and kind of flat, like super flat. Torus geometry. Why is it so flat? Is it because there's no detail here? I bet it is. Yeah. I don't like these settings. I'm going to make it 8 and 64. And then I want to scale the ring down. So Saturn ring dot scale dot z equals some small number. And it's going to flatten out that ring. Also, make it a little wider. This is controlling the kind of the width of the ring, and that did it. Now Saturn has a nice ring. I'm not casting a shadow right now. That's just the way it's going to be. I think I'm going to make this a little bigger and wider. How's that work? Does that look good? I think that's better. It's a little bit heavy. Like I feel like Saturn's ring should be lighter, but what are you going to do? Great. Saturn was a lot of work. Let's move on to Uranus, which is also going to be a lot of work. I don't like how far out it is either. I mean, I get that this is probably more physically accurate or closer to what's happening in real life, but who cares? That's not the goal of this exercise. Let's put that at 3.75. And we've got Uranus or Uranus. Uranus has a ring too. I'm going to copy all of this, changing some of the values, and let's make this U ring and call this Uranus ring. All right. It's not as wide. Let's put it at a 5. And it's a lot narrower. But everything else will be the same, I think. Oh, and I'm not going to rotate it. Instead, it'll be like Saturn, kind of like... no, sorry, it'll be like Uranus in real life. Like Uranus in real life, where it's kind of on its side. I didn't pass it in as a child yet, though. Children... And that's Uranus ring. That's not going to go well. Cool. Because of the random rotation I'm doing, it doesn't really look like it's vertical. There we go. It looks like it's vertical there. One planet to go. Let's add it. That's Neptune. Beautiful. We've done a lot already, but let's finish it up by adding a bunch of lines around the elliptic plane just for the fun of it. We could just step here and animate the camera, but I want those lines because I like the way they look. That's going to be, say, const elliptic lines equals get elliptic lines. Thank you. Scene.add. Why scene.add? Why not? Oh, because I put it down here, I guess. Sorry. Let's move it up here. And make that solar system.add. Elliptic lines. I haven't defined get elliptic lines here. Let's import get elliptic lines from... Oh, that's weird. Why did you do that? Don't you know I have it in this directory too? And there's all those lines. Last thing I want to do is to animate the camera so that we can just have a broader view of our scene. I'm going to add a toggle const use animated camera. And then add a if statement in our render loop right here. Right. And say, if you use animated camera, then the X and the Z position get the sine, should be cosine and sine, of time times 5. Oh, okay. Yep, and this should be camera distance, like so. Camera distance is equal to 5. And look at 0, 0, 0. If I don't add this look at, oh, else. Use the camera.update method. If I don't use it, we get this really cool kind of cinematic intro where we kind of pan across the solar system. Scale doesn't feel quite right. But then we're gone again. So if you add this, now we're looking right at it. It's a little far away, I feel. I'm going to get a little bit closer. I also want to animate the Y axis as well. Let's do it like this. And we don't care about that. This is just a subtle movement up and down on the Y axis. And there you have it. If I had more time, I'd love to go into the details of how I set up each one of those little helper modules. Let me know in the comments below if you'd like me to dig in there. Otherwise, you can just check out the repo and look at it yourself. I suggest you take this and play around with it. You could refine the scene by adding bump maps to all the geometry of the planets. You could use selective glow to make the sun really glow and maybe some of those elliptic lines. Try animating the asteroids or those lines. You could add physics so that the asteroids kind of collide with each other and bounce off each other inside of the belt. You could also add particle effects, same thing, distribute particles all along the asteroid belt or the Kuiper belt or the Oort cloud. Lots of stuff to do. If you do create something, create a JS fiddle and share your creation. Thanks so much for watching. I'll see you next time. And as always, thanks for stopping by. Bye.